好，同学看起来好一点了哈。好，那我们就继续吧。It looks like the connection is good right now, so let's continue, okay? Um, After we prepare, okay, our text-based data set and those labels in the file directory structure, okay, and we simply just use a very simple utility called text data set from directory to create our validation data set, training data set, and testing data set. Okay. After that, okay, we have to make sure all the data set in our data set is quite preprocessed. Okay, so here we can see that here is a customized standardization right here. So you can use your own customized preprocessing in this right here. Okay, so you simply just write whatever the structure like this. Okay, you have an input data right here. So the very first thing is that they do the lowercase, which means they would like to make all the data to be lowercase, so that when you analyze text-based data, it can be we have only limited tokens, which we do not differentiate capital words or lowercase words. Okay, and right here is that because the text data is from web-based movie common database, so there are some HTML, which is the web text, which is should not be analyzed by your model. So it replaces the some HTML tag by using white space, because white space is then be used to fragment different words in the sentence. So I think they think to replace those text, HTML text, by using white space is quite reasonable. Okay, and here again, they do punctuation. They deal with the punctuation. So basically, the standardization to preprocessing this data basically remove the punctuation, remove the HTML tag elements to simplify, and do the lowercase to simplify the text-based data you collect from the internet. So I think that is the quite standard things you need to do. Okay, so that's standardization. And the next thing is tokenizer. Okay, here we have a vectorized layer. So basically, TensorFlow has its text vectorization layer. So basically, simply just as what we introduced in the previous in the previous class. Okay, we have right here. There are two different parameters. Okay, the first one is for each text-based data, how did you do customized standardization, which we defined in the previous function, right? And right here, the maxima tokens, which means how many words in your dictionary. So right here, it has 10,000 words in the dictionary. So basically, the dictionary, I think the very first the very first word is empty, and there are some other words, for example, and I think the last word should be unknown, which means because we have only 10,000 words, but you know English should have even more words. So they will do ranking. So right here, if the words you used in your database, okay, they might be much more than the max feature, which is the max token, the most words in your dictionary. Okay, so only 99,999 words will be picked from the dictionary because they are mostly used. But all the other words which is not in the top 99,999 words will be replaced by a unknown token because you have only 10,000 dictionary in your settings. Okay, and here sequence length, because the comment might be very might be short, might be long, which is quite different. So it says at most the model accepts 250 words. So the comment which is more than 250 words, all the words behind 250 words will be discarded. Okay, so you have to think about your applications. It is fit how many tokens you would like to use, how many words in your dictionary. Because it is English, so I think 10,000 is quite feasible. But for some applications, it's not. For some very small corpus or very small text-based analyzed application, you don't need 10,000 words. And the second thing is how long your sequence can be. I think 250 words for a comment is quite feasible, quite reasonable. But for some logs, it can be very long, so you have to set it very, very long so that we can observe the difference between normal text and abnormal text. Okay, I think that is the things you would like to know. Okay, and the next part is adapt your training text to the vectorized layer. So your text will be pre-processed by the vectorized layer, including the customized scenarization apply, including it will help you to count how many words in your text in your training data, and they will use a 10,000 dictionary to describe your text, and they will discard all the text behind 250 the length of 250 words. Okay, so that is okay. So if you take one of these, so that is if you take one of the example right here, right? So you take one batch right here, and you take the very first text and labels from that batch, because we mentioned before, for each batch you have 32 different comments and labels, but you take only the first one. So you can print it, you can know what is the label it is, and then you put those vectorized tests. You put those the first review and first label into your vectorized text, okay, which is right here. So it will print what is exactly the model received. So basically, there are 250 elements in this array because we set it to 250. So for each element represent one token in your dictionary. So 68 refers to the 86th words in your dictionary. That means the 17th words in your dictionary. So from now on, you don't have to deal with the text problem. from now on, you have a dictionary, you have a very nice mapping. And here is how you transform your text-based data to a numeric data. And the size is quite long, as you mentioned before, because there are a lot of zero. Zero means padding, right? Means padding because you have to pad your text to 250 tokens. So from now on, it is your input data to your model. Okay, so of course there are certain interesting things that you can simply just use the get vocabulary, this specific function to know what exactly the token is. Okay, is that okay? Okay, let's take a look at the next one. So basically you simply just that your all of your training data, validation data, and testing data to pass through the vectorized test. So then we have train dataset, validation dataset, and testing dataset. So all the pre-processing will be done by the vectorized text. That is a function. Okay, so I think that is all the pre-processing things you need to do before. Okay. So after that, you need to create the model, right? So basically, you can see below there is a TensorFlow sequential model, okay, which is TensorFlow sequence. So we can see that. Sorry, we can see that there are several different layers right here. The first one is called embedding. The embedding layer is quite important for text-based because once you have such kind of indexed, so as we mentioned before, when you do pre-processing, your result will be like that. Okay, after you do pre-processing, your result will be like an bunch of a list of index. The index is the dictionary, the dictionary index, right? So all those index will be transformed into some other decimal representation by using layers embedding. So of course you have to give it maximum number of the maximum features and the embedding result right here, so that your index list will be transformed into 16 decimal numbers, and the 16 decimal numbers will be represent all your sentences. So that at line number 2, that is a result. Okay. So after that, we of course this is a very simple text, very simple neural network. So it has a 20% dropout. It has a pooling layer, and then it has a dense layer. So that is a very simple. So you simply just apply this this model. Okay. So here we have the summary of this result. So you have to make sure you set the correct number of settings. For example, how many dictionary you want to use, how many